Okay, let's get this geometry thing going. When last we were here, we had this super cool coordinate plane that I finished making. Guess that was like, I think that was Monday that I streamed. So check out this cool coordinate plane that we got going on here for all of our math needs. We could do all sorts of stuff on here if we wanted to. We could graph something or, you know, whatever. It's kind of funny to look around and notice extra rendering happening. I wonder what, I don't know that I've explored over here. Which direction did I go that I found a sand temple. Kind of curious about which direction that was. Okay. So, got myself a nice tower here. Why don't I had emptied a bunch of stuff out because I was planning to take on some pillagers, but the pillagers disappeared on me, so I'm gonna do some exploring, I think. So I'm gonna go ahead and grab some more things in case I need them. What else might I need? I guess that's... oh. That's a lot of seeds. I should start myself a farm. Alright. So, I am really bad at not knowing where stuff is once I leave, like, the place I start out from. So we're gonna see how this goes. I went a direction on Monday and found a sand temple, and I don't know what direction that was. I guess it's probably the flattest direction. Oh, hello cows. Nice to see you. And the topic I want to discuss with you all today is... boy, this cow is not happy about me attacking him. Go figure. Talk about reasoning and proof. And so there is some vocabulary to this, as there is with just about everything. Part of me doesn't like killing the cows because they're just so feisty. So the first thing we have to kind of talk about is how we reason. So a vocabulary word is the word conjecture. A conjecture is a statement that we believe to be true. And you can imagine that you might make a lot of conjectures in your life, and actually you make a lot, but you think even more, some without even really realizing. Hey, Abby. Because we just make so many assumptions in our lives, and we assume that things are true, and we actually do that using most of the time some sort of reasoning. Every now and then we might just have completely flawed reasoning, but most of the time we've got a reason for what we're doing. There's two types of reasoning. Inductive reasoning is the process of reasoning that a rule or statement may be true by looking at specific cases. So you think something is true because of specific cases that you've seen, like so it takes the specific and makes a general rule out of it. And then deductive reasoning kind of does the opposite in a way. Deductive reasoning is the process of using logic to prove whether all cases are true. So we typically do some of both in math, but at least in geometry we try to use deductive reasoning a lot. We want to have logical step-by-step thought process to how we decide what we're doing. how we decide what is true. And so what we've done up until now, where we've just looked at some definitions and some postulates. Hi, Abby. Did you hear me say hi the first time? Is my sound on? Hello, hello. Hello. Let me know if you heard me say hi. Oh, yes. So, hi, Alex, as well as hi, Abby. And what was I saying? Oh, there are definitely times that you can use inductive reasoning in math. There's actually like this thing called proof by induction, that if you know what that is, and you're like me, you may not actually be much of a fan of that. Like, it's kind of a cool thing, but it's also, I don't know, sometimes has brought fear into myself. There is the sand temple right there. Okay, so one way that we reason is we say, okay, these things have happened to me. Hi, Sarah. We say, these things have happened to me, and so I'm going to assume that this is true. That's a conjecture that we could make. A bunny rabbit! You guys, there's a bunny rabbit right here. Look right here. Look right here at this bunny rabbit. This life is great because, look, I found a bunny rabbit. I'm not going to kill this bunny rabbit. I don't know if you get things for killing bunny rabbits, but I'm just going to choose not to. I don't know. My day is almost over. How'd that happen? I just started playing. Okay, well, I'm going to go back home, and I'm going to remember which direction I came to get here. We're going to check it out on the next day. Okay, I don't want to fall in that hole. Go this way, go that way, bob and weave. I think this is the right way to my house. Oh, there we go. See, I made that nice tower so I could tell which direction it was. And I kind of feel like I need to make like a statue-esque sort of, oh, that's not good, thing. Like something to remember, hey, this is the right direction. This is going well. Okay. I got to go. I'm not so good with the zombies. Well, the zombies actually are not my worst. It's just them in general. These people that attack. So, some reasoning. So, where's a zombie? Really, I just don't want a creeper to blow up my coordinate plane. I don't know if you guys saw it. Let me show ya, because it is pretty cool. Check it out. We got a X and Y axis. We got a zombie over in the third quadrant. Hi. Hi, man. I got you. See ya. Oh, see? That's what I was worried about. No. That's okay. We won't graph in this quadrant much anyway. Right? Right. You know, it took me way too long to realize that, creepers, you don't hear them. They creep up on you. I am afraid that I may die because of this person. And I have not actually died yet in this game. Right. I'm just gonna cower over here for a little bit. And hope for the best. This is the kind of thing that makes me think, oh, I should just build an intricate tunnel system everywhere I go so that I'm never actually outside. That's my feelings on this. Here's my house. Home sweet home. Okay, so deductive reasoning. would be, no. I don't know. It is actually hard to tell the difference between deductive and inductive reasoning a little bit. And I don't have any super good examples in front of me. So, there you go. We do have some reasoning we can do. We've talked about some definitions and some postulates in some previous streams. And then that leads us to starting to make theorems. A theorem is a statement that you can prove is true using a series of logical steps. And so there are lots of theorems. You're probably already familiar with the Pythagorean theorem. There's a creeper right there. Oh, thanks, Sarah. Yeah, I'm pretty excited about the 1K. Very excited. And spiders I don't like, but I'm not as worried about as the creeper over there. So I don't really want to fight all three of them at once, though, that's for sure. Maybe I'll just sneak around. Doo-doo-doo, doo-doo-doo-doo-doo. There's nothing to see here. Okay, well. Hope they just, like, wander off somewhere. 'Cause I'm going this way. Alright, so one of the frustrating things in math is that when you prove something, you have to prove it for all cases. And if you're just kind of thinking about what that means, like, you have to prove it that it always works, or you can't say that it's something that's true. And so if we're talking about, like, if I made the conjecture that all odd numbers are prime, that's something that is not true. Not all odd numbers are prime, but it could be that I was only looking at the first few, and that seemed like a good conjecture to me. So just because a few things work for it does not mean that it's something that is true. And if you can think of a counterexample to a conjecture, then you've proven it's not true, and that means that you should go back to the drawing board on your conjecture. So for my example of all odd numbers are prime, I would just need to think about the number 15 would work. 15 is a counterexample because 15 is odd, but is not prime. Okay, I am at a sand temple. I've never been to a sand temple, and I do not know what this is going to be like. I am very, very afraid for my life. I was told that it was easy, but I have a habit of making things harder than they have to be. Also, I'm kind of terrified. So, if you have a conjecture that you're like, oh, I think this is true, then you prove it using logical steps. You can use, stairs. You can use definitions, you can use postulates, you can use theorems that have already been proven to be true. And if you can manage to prove your conjecture to be true, then you can use that to then build and prove other stuff as well. I was told, I'm pretty sure, not to touch the blue, but maybe I'm wrong. Should I touch the blue? I don't know. I just don't know. There's stairs. Not sure what to do here. Maybe that's not the way that I need to go. This is the exact same thing. Oh wait, was that the thing? Oh, that's where it just was. Part of me just thinks, why don't I just dig into this, right? Just dig a hole. So the counterexample thing can be kind of frustrating because that's one of the things that your teacher will likely ask is they'll give you some conjectures and ask you to either say that the conjecture is true or false. If it's true, prove that it's true. If it's false, give a counterexample. And what's actually the easier thing to do there is if it's false to provide a counterexample. That's going to be the easier thing to do. If you can think of a counterexample. And so my suggestion to you would be to say, well, is it like think of cases and be like, is it true for this? Is it true for this? Is it true for this? Okay, well, I guess I should start trying to prove it's true. And depending on where you are in math would be like how tricky that situation of proving it might be. I feel like the only thing I can do here is go in the middle. Like, other than just digging. So, this could be a bad idea. Or this could do nothing. This did nothing. Okay. If anybody knows anything about sand temples, I know nothing about sand temples. I do not remember what I was told in the last stream about sand temples. Other than that, this is, in fact, a sand temple. Like, it's my understanding that there might be treasure or something. Maybe somebody's already taken the treasure. I don't know. Maybe it's just an empty temple. This is the same thing, right? It's just the other side. Well. I guess that there's nothing to this. This was fun to explore. I suppose I'll be going back now. We're going somewhere else now. It was fun to see bunnies. That kind of looks like a question mark. That looks kind of temple-like over here. Like, is there more to the temple that I haven't seen? It seems wrong to, like, dig into this and ruin. Ow, I fell into sand and it hurt. Yeah, right. So, we can... If we have a conjecture... Ooh. If we have a conjecture that we think is true and we're asked to prove that... Ow, no! We're asked to prove that conjecture is true, then, ooh! I feel like the sun did part of the work there. Do you hear that? That's it. That's all that's down there. Give me back my... if we're like, okay, I think this is something that is true. There is a spider down there. Then we can try to start the process of proving that it's true. And that's kind of a tricky process. There's a lot that goes into that. Should I, like, dig here? I know there's a spider down there. I definitely want to be able to get back out. So... let's see. So proving things is quite the process, and typically you won't maybe have seen very much proving until you're in geometry, and you probably won't be asked to prove anything before geometry yourself. But geometry is the place where most math teachers decide, okay, we're gonna go ahead and do some proving. It's a really like just incredibly normal thing to do. So if you are already into proofs and you're frustrated about it, just know that pretty much everyone else goes through the same thing as you. I don't know if that makes you feel better, but there it is. Going down is so much harder than going up. Without, falling to one's death. Also, not sure that I want to come down here. Also, spiders, I find spiders terrifying in real life. They're not much better in Minecraft. In fact, maybe they're not at all better. I want to say. Don't want to fall. Definitely don't want to find out that there's actually a ton of spiders here. Oh, I see two. So, it's not great. But also not bad. Okay, we've ended up at the same height that we were. Haha! Take that. I was thinking about coming by after school tomorrow. Come on, jump higher. You can do it. What are you doing differently now that you can I help you out here? Without dying? There we go. There can't be much left to him. Come on, jump, jump, jump around. Jump, jump. There we go. One down, one to go. Let's see. I do not want to fall. I'll be very impressed with myself if I manage not to fall, because I'm really bad about falling. That other spider is around here somewhere. Probably just waiting for me to give him exactly what he needs to defeat me. Not today, buddy. Maybe I will have walled him away from me, actually. That would be great. So some of the first proofs we usually see in geometry are actually algebraic proofs, which is funny because we, typically have just had an algebra class, and then all of a sudden it's like, here, prove some things algebraically. There's a creeper over there. And there's a creeper right next to me now. Where you at, bud? So they'll actually set you up with just like, hey, here's this equation, here's the answer. Like, show the logical steps that get you to your answer. Because we can use properties that we know and love from algebra that we last year in Algebra 1 just got so used to using that we don't even really think about the fact that they are properties. Hey, I did not know that that was, that he was down here. That was pretty fast for me to get rid of that guy. Hello there? Don't blow me up. Don't blow me up. Well, he didn't blow me up. Did you blow up the spider by any chance? Because that'd be handy. But I don't think I'm that lucky. I feel like there's... Ooh, iron. Part of me thinks this was a terrible idea on my part to explore down here. What was that noise? Oh, snap! A witch! Oh, snap! Oh, snap! Oh, snap! Oh, I'm poisoned! I think that this is the end, guys. I think this is the end. I think I have, like, no hope. I think that I don't know. Hey, Creeper, can you blow up that witch so I don't have to deal with her? Did you blow her up? Nope, doesn't sound like it. Does this go away ever? I feel like I'm gonna die. I have, like, armor on. I'm sad. I'm so sad. Oh, 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 it went away. Oh man. I kind of would like to leave, but
wood to make a chest.
also no. I do not have enough wood to make a chest. That would be a great idea. But what if she's dead? Nope, she's not dead. That's the witch. Wait, is that the witch noise? But then I'll see her coming. Yeah, that's definitely the witch noise. Let me out! Let me out! What? Like, I built my way down here. Like, it might be easier just to make my own exit. Well, this has turned into a fun place to be. I'm just gonna try to kind of like dig my way out this direction. Kind of an up and over sort of situation. And maybe I'll come back once I feel a little bit braver. Probably should put a torch. Oh, that could have been bad. I don't actually know if sand hurts like gravel does, but I assume it does. And it is night, and there are scary noises. I would like to leave. Although I don't know that outside is going to be any better, because, you know, there will be monsters outside. So kind of feel like I'm stuck between a rock and another rock, which is actually exactly how I could describe the place that I'm at right now. It's between rocks. It's my understanding that the that milk will cure the poison of a witch, so maybe I should make myself an iron bucket. And, hey, what are you? What are you? What is that? Did he just bite me? I've never seen a zombie like that before. Hey, 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 hey! I think that this is not where I want to be. Oh, look. Light. Okay. We can do this. Maybe those are like sand zombies? Are there different kind of zombies for different biomes? Not gonna look at that Enderman. Gonna stay away from that Enderman. And the direction that I came from to get here is hard to know. Whew. You know, doing math I feel like would be less stressful than playing this game sometimes. I don't think I went the right way. Still not really the right way. Hey, I found my tower! That tower was such a good idea. Whew. Whoop. Pardon me while the smoke detector goes off. Just for like a little bit. Ah, my heart is still racing a little bit, if I'm being honest with you. Okay. Put some stuff away. I guess I do have enough stuff to actually fix where the coordinate plane got blown up by a creeper. So that's something. I'm curious if there's anything cool you can make out of cactus or cacti. I'm doubting it, but I thought I'd check. Will you show me what I can do with a cactus? Wait, what was that? Ooh. Interesting. Alright, well, I don't know. I guess I'll figure that out some other time. That was a real drain on my food supply. Not surprisingly. I guess it's good that I killed a bunch of animals randomly on my way exploring. Yeah, so in this section I'm looking at, we've got different properties of equality. So the addition property of equality, or the subtraction property of equality, which those are just the things that when you're solving an equation let you add things to both sides and say it's still equal, or subtract things from both sides. We can multiply on both sides, so that's the multiplication property of equality. We've got the division property of equality, And those are all the operations. So then we've got some properties that I'm going to be honest, you know, the first one sounds really, really dumb, but you do end up using it. The reflexive property of equality says A equals A. It's like, okay, who decided that was a thing that we needed to specify, right? A equals A.
Apparently some need it more than others.
But it is something that does come up as you're proving some things. I can think of an example, but it wouldn't do me any good to talk about it now if you're actually like following this like through and you're at the beginning of geometry. So that's called the reflexive property. Think of it like your reflection in a mirror, like you see yourself. That's how I think of it, how I remember what it is, that you're basically talking about you see yourself. It's the same thing on both sides of the mirror, right? Right. The symmetric property of equality says that if A equals B, then B equals A. And again, it's like, okay, why is that a thing we need to state?
Again, some need it more than others.
And people are really specific about proofs, so there are times where it just matters that you turn things around, that they might care about that. I'm having trouble off the top of my head thinking of what would make us use the symmetric property right now. But we actually we do use the symmetric property when we're solving equations without even thinking about it. Anytime you solve an equation and you get like 4 equals x, but then you write down x equals 4 because it feels nicer to do it that way, every time you do that, you're using the reflexive property. You just maybe didn't know that that's what it was called. So, ta-da, go figure. I have iron. I'm going to make myself a bucket, and I'm going to get some milk. And if I run into a witch again, I can cure myself of poison. And it's going to be totally awesome. I think that's the strategy that one is supposed to employ. Okay, let's go find... Oh, look, it's raining. Oh, nice. I just love rain. And then, so the next one is one that, again, should make sense. And maybe even to the point where you're like, well, why do we need to even say this? But you do use this one again. It says if A equals B and B equals C, sorry, if A equals B and B equals C, then A equals C. Okay, so, can I milk you? I've never actually tried to milk a cow before. That didn't work. Oh, Oh, now it worked. I have milk. Do you have milk that you can give me again? Or did I... Oh, I think I drank it the first time. Okay, so now I have 2 buckets of milk. So that's nice. Pretty excited about that. What time of day is it? I just kind of noticed, like, it's like heavy rain and it's not even that cloudy. So that's weird. That's very weird. And then finally, the substitution property of equality. So if A equals B, then B can be substituted for A in any expression. That is something else that we use actually in algebra a lot. This idea that, you know, if x equals 5 and you have an expression that has an x in it, you can replace the x with 5. So these are things that you may have talked about them when they were introduced as property. Like your teacher may have said, hey, this is a property. But after that, we really just kind of like internalized that, oh, these are the ways that we can do things with our equations, and we don't really think about it anymore. But we use these quite a bit in algebra to solve things, and we're going to end up using them in geometry as well to prove some statements. Maybe this will help me find my way home better, having a tower right here. I don't know, I feel like I should probably make it taller. We'll see if this helps. So I did not appreciate not knowing which direction I needed to go last time. Well, that's quite a drop. Also, I think it's about to be nighttime again. We know what happens when it's night. People come out, and it's scary. Apparently I need to add, like, another marker. Because that almost went the wrong way there. So... I am not quite beating the sun home. If the sun's setting, is it going home? I just would like to not have creepers come and destroy my hard work. That's a thing that I would like to avoid. Very interesting sunset while it's raining here. Okay. I also feel like I want to take a chest with me so that if I get panicked that I'm not going to survive, I have a chest that I can throw my stuff in. Seems like a good idea. What am I missing? Oh, no, I don't know. Yeah. Alright. I don't even know what why I'm going back over there, actually. I didn't actually discover anything. I don't know that it does me any good to get revenge. I guess I found iron down there that I didn't actually mine. So I guess that could be good. Let's see. This way. So one of the things we can prove pretty early on in geometry is called the linear pair theorem. And so you may know that if two angles add together, if you add two angles together and you get 180, those angles are called supplementary angles. That is a definition, like just if two angles add up to be 180, we call them supplementary. And so the linear pair theorem says if two angles form a linear pair, then they are supplementary. So what does that mean? Well, let me show you. If we have a straight line, here, got ourselves a straight line. If a linear pair is where you have something coming off of this line, so it's talking about this angle here and this angle here. They're called a linear pair because together those two angles make up one side of a line. So it's a pair of adjacent angles whose non-common sides are opposite rays. So rays that make a straight line. So this way would be a ray, and this way would be a ray. And so this theorem is saying if you have two angles that form a linear pair, so together they make a straight line, then they are supplementary, which means that these two angles add up to 180 degrees. So in some ways, maybe this feels like more of a definition than a theorem, but we're kind of equating this idea that what we look at, which is called a linear pair, if I can look at it and see that it forms a straight line, then I can know something about the measures. So there's this thing we do where we connect what it looks like with what their measures are, and that's going to be an important thing actually in proving things. I kind of want to look up sand temples real quick, because if there's no reason for me not to, I'm just going to like demolish it with my shovel. Minecraft sand temple. The hidden lower chamber of the temple. When attempting to enter the hidden chamber, the player must take care not to step on the pressure plate at the bottom of the pit, as the plate is connected to 9 blocks of TNT just under the hidden chamber's sandstone floor. That's a lot of TNT. The pressure plate is situated directly under the blue terracotta. So we saw the blue. To avoid the trap, you can dig out one of the blocks orthogonally. I cannot believe this Minecraft Gamepedia article uses the word orthogonally. I don't think I've ever heard that word in anything other than a math context or physics context. The word orthogonally is a fancy word for perpendicular. My mind just got blown by that. Okay. I have new information about this. Digging was the answer. So, underneath this room is a hidden room with treasure, and I am going to find it. Whew, okay. I can do this the long and annoying way and hope that doesn't come back to haunt me. Never know. You never know. Ooh, iron. See, this was already worth it. Maybe. More iron. More iron. I feel like can't imagine the treasure being better than this. At this point in the game, at least for me. I'm so turned around, and I have now dug deep. Which direction is the thing? You know, I'm regretting not bringing more pickaxes. Hello, Sharon. Okay, well, I can see the treasure room, which is good. Is that it? Now I'm safe? Ah. Gold!
You bypassed the traps.
Diamond? Wow, I can't believe that I didn't realize that that was diamond, and I just looked at the gold. That's pretty exciting.
Much time.
3 diamonds. I don't feel like that rotten flesh is needed. An emerald, an iron, some iron horse armor, gunpowder. I just realized that this is a cooler way of picking up this. Gold. Okay. Golden apple. And a saddle. And more diamonds, 2 more diamonds. Well, now I definitely want to get out of here alive. How does one mine TNT? Does one mine it with a hammer? This seems important. Dig out. Should I take that literally? That dig out means use my shovel? Yes. The shovel worked. This is nerve-wracking. Hello, Sharon. Are you saying something in English? Because if you are, I don't know what you're trying to say. I only happen to speak English. Okay, how did I get down here? Over there? Now I climb back out and hope that it's still day and I can make my escape back to my house with the greatest of ease. It is still day. That was very quick. I'm super excited. And I can see my tower, so I know which direction to go. This is working out way too well, I feel like. Diamond is an amazing find. Especially considering that I did not have to go digging a deep mine to make it happen. Because now I can make a diamond pickaxe in case I run into obsidian. I don't know that that's really the best use of diamond, actually, if I'm not planning to mine a bunch of obsidian. That is hard to say. Come on, you can make it. You can make it. We can do this. We're almost there at that tower. That tower's our home. Here we go. Even if we do die, there's a good chance we can recover our stuff at this point. Stay, son, stay. Don't go down. We're getting there. I almost feel like from a distance I saw those pillagers that have been hovering, but it's so far away that I don't know. Nice. Nice. Oh man, I feel so rich. Let's put these bad boys away. Need to use that blue terracotta to decorate. Do I have string in here yet? Oh, I can make a bow now that I've got string. And I think I am like now out of room. So that's a bunch of different kinds of sandstone. That's kind of annoying. That's not where I meant to put that. I'm trying something that I was told worked, and I don't know if it actually works, or I don't know how to do it, one of the two. So, I was told that I did it! Okay, well that's not what I thought that person meant whenever they told me that originally, but I figured it out. So, it's all good. It's all good. I've got gunpowder, I've got TNT. I don't know what people actually use that for. Obviously they use it to blow things up, but like what? Like, do they use it for mining, or I don't know. I don't know what people use it for. Do I have more coal? I have more coal. Why can't I use this now? Okay, never mind. We're good. Oh, that's all I can do? Okay, that's fair. What is that? A loom? What can you make with a loom? Can anyone illuminate that for me? I hear a bad guy. He's gotta be down in the mine, because otherwise he would be on fire. Right? I just hate how close they sound. Yep, look, there he is. You got friends? Or is it just you? Hey, buddy. Are you knocking on my door? Oh, look behind you. Look behind you. Oh, he just hit me through the door. That was rude. Oh, and now he's going away? Did something actually happen in there? Am I being dumb for wanting to see if something is out there? Yes, I am. Just gonna go back this way. See, like, oh, I'll just come out the front way and burn to death. Okay. That's cool. You do what you gotta do. Okay, well, that was some excitement with the sand temple. So now we're on to, I gotta maybe talk some math now. Let's see. Anything going on around here? Those pillagers back? Nope. Where should I, like, I feel like I should build a new house. I kind of want to build it behind my coordinate plane right here. I don't know. And then there's the decision of what to build it out of to make. So, I also kind of, I wonder, like, maybe I should wall in my coordinate plane, because then creepers won't come. In theory. I wonder, can creepers, would they just fall down? Probably. Probably. So I was talking about the linear pair postulate, so the fact that if two angles make a straight line, that then they're supplementary, so that means that their measures add up to be 180 degrees. So typically you'll see that used to have you do a little algebra to find angles, or you might just use the segment addition postulate or the angle addition postulate, and they'll basically just assign the different parts of your figure some algebraic expressions, and then it's really just a matter of you knowing, should I, in this situation, add these together, or should I set them equal to each other? Because if you have, well, I think actually in all three of those cases, most of the time we would just add together and set equal to something. So for the linear pairs, you could add together and set them equal to 180, because if they're a linear pair, they add up to be 180. For our segment addition postulate and our angle addition postulate, I think the same is true. The time where you might set something equal to each other would be like if you had a bisector. So a bisector cuts something in half. You can do that with segments, or you can do that, or I mean lines or segments, or you can do that with angles. And so if you know it's a bisector, if they tell you that, then that's when you should set them equal to each other. But otherwise, you're probably adding up or subtracting maybe to get it to equal something. All right, we're talking geometry, right? So I'm gonna make I don't know if I want to make a square or a rectangular base. We'll call it a rectangular base, and then if it ends up being a square, we're technically not wrong. Just had a cool idea about having like walls around the coordinate plane, and then having a door that I can get in through. So I was like, how am I gonna make this work so that bad guys can't get in and mess with my stuff? I think that's the master plan. And then back here will be my house. But I do need to figure, oh no, don't do that, what to make it out of. If you are watching this and you have an opinion on what I should make my house out of, comment below on this video, because I would love to hear what you have to say. And you know what? If everybody votes for obsidian, I'll be a little frustrated, but we will make it happen. Oh man, that trader scared me. The traders always scare me. They are terrifying in their own way. I mean, not really. They're not really that scary. I like symmetry, which is a very human thing to like. So I kind of want to make this the same on both sides, like length and width. With kind of centered with this. To realize that looks kind of funny. But I don't know. And then sometimes I just end up like continuing to dig things and making them bigger. And that's a problem. So I gotta stop at some point. I can't just make it infinitely big. especially not if I get a bunch of obsidian bits. Okay, so we're ready for some more postulates. Nope, I'm gonna actually go back to my house and call it a day here, and then we're ready for some more postulates, because I was gonna actually use the coordinate plane to talk about some of these postulates. Boo. It is night. You don't know what you're talking about. I may almost have enough stuff to be ready to actually try to organize all this. Looks like I need a shovel. I have an iron shovel. I don't know that an iron shovel is like used for anything specifically, so we'll see. We'll see. Okay, so the postulates we're ready for now are some of the... So I'm actually having trouble remembering. There's 5 of them listed here. Euclid is famous for geometry, for Euclidean geometry, and in particular, his postulates have made a big splash. Postulates are supposed to be things that just make sense, that we can easily convince ourselves that this is true. Hello, zombie. You are on fire because it is daytime. You gonna make it this far? Okay. All good. So first one being, and if you've watched some of my earlier streams, you've already heard me say this. Through any 2 points, there's exactly one line. So this is something that you can pretty easily, I think, convince yourself of. That if I have 2 points and I draw a line through them, there is only one line that goes through them. Because if I try to draw 2 lines, then it really is an issue of whether lines are straight or not. If we consider lines to be things that are straight, then yes, there's only one line that goes through these 2 points. And I would just connect it right here and make it go through there, and that makes sense. There's just that one line. And it's actually like an interesting thought to say, well, what if they don't have to be straight? What if they can be curved? Because if lines can be curved, and if we can still do geometry with curved lines, then that opens up a whole realm of possibilities. That's actually a type of non-Euclidean geometry, is where lines don't have to be straight. And so this postulate is not something that is true. But for our Euclidean geometry that we learn in high school, it is true that since we're doing straight lines, there's only one line that goes through these 2 points. The next one is, through any 3 non-collinear points, there's exactly one plane. So 3 non-collinear points. You can actually have 2 of them be collinear. In fact, 2 of them will be, because you just need 2 points to have a line. But the third one should not be on the same line, is what it's saying by specifying they're non-collinear. So if you have 3 points, there is exactly one plane that contains them. And so what that is talking about is how, if I can imagine there's one plane that goes through all these points, it'd be a plane just above my coordinate plane. If I move this point even a little bit, then kind of the byproduct of this postulate is if I move it even a little bit, I now have a new plane, right? That this plane is a little bit slanted. It is not parallel with the coordinate plane that I have here, because it's got to slant down to hit those points. So that's a different plane right there. So any 3 non-collinear points has exactly one plane that contains them. Let's get rid of this one. If 2 points lie in a plane, so here's our 2 points. I'll go ahead and, may regret this, but I'll go ahead and turn this into a line real quick. So we've got 2 points, and we've got a line, so it goes on either direction. This way, this way. Okay, here's our line, 2 points. So if 2 points lie in a plane, those 2 points, like, they're on top of the coordinate plane. Let's just pretend that they're a part of this, like, mystical plane that's, like, the layer above the coordinate plane. So I don't have to dig up the coordinate plane to put them inside of it. If 2 points lie in a plane, then the line containing those points lies in the plane as well. So that should make sense, right? That if we're talking about a surface going on forever. These points are on that surface, and so the line that goes along them also is on that surface. To be honest, I don't know why that's important, but it's a postulate, so we must use it later, I guess. If two lines intersect, then they intersect in exactly one point. So that is only true if that first postulate I said is true. That if through any 2 points there's exactly one line, if we say that's true because we're only using straight lines, then it's also true that when two lines intersect, they intersect at exactly one point. So I could draw another line. I'm going to try something other than a right angle here, because I need to branch out as I make this out of wood. I need to branch out of what I'm doing. So here we've got this line and we've got this line, and they are intersecting at, this is kind of tricky because of the way they're intersecting and because of the angle I did, but they're only intersecting at one point. I know I kind of made it look like it's at 2 points, but really it's more addressing the fact that like these are straight lines, so they don't loop around and intersect somewhere else. I don't draw this line, I don't curve it around and make it intersect over here as well. That's not the kind of thing we're trying to do. So if two lines intersect, they intersect in exactly one point. And then kind of a similar idea to that, if two planes intersect, then they intersect in exactly one line. I don't have enough wood to make another, oh, that's not what I wanted. Come back. So that would be the idea that here we've got a line, and if instead of this being a line, if we turn this into a plane, okay, if this plane is going to end up being perpendicular to the plane I already have, the coordinate plane, more dirt, more dirt. Now, keep in mind our planes go on forever in reality. Well, yeah. In our theoretical math reality, these planes would go on forever. And I say that because, like, if we are actually in the real world, then there are planes, I guess, that we could talk about going on forever-ish. But I think the idea is that in real life, things tend to end at some point. Okay, let's not get into that. This seems like a whole other conversation to have that is not necessary right now. So we have two planes. We have the bottom plane, which is our coordinate plane. This plane is sticking up. Let's pretend it goes up and up forever. This postulate is saying that if these two planes intersect, which they do, then they intersect in exactly one line. So this is the idea that planes are not curved either. That planes are actually... it's almost like they're made up of straight lines. And so since our planes aren't going to curve either, then think about how planes would intersect. They would have to intersect at a line. Now, if we start talking about three planes intersecting, then things can get interesting. But if it's two planes, they intersect at a line. So then if you know all these postulates, then you can start drawing some kind of interesting figures. And either be given a figure and be asked questions about what's happening, or they could give you a description and have you try to draw that figure, which that would be sad because three-dimensional figures especially are really hard to graph. So that would be that would seem frustrating to try to do. Good thing I dug up all that dirt, huh? So I would have dirt for this plane. Now I can get rid of it. But we've now kind of got the building blocks available for some of our first proofs. We can do some algebraic proofs for sure, but we also are getting ready to kind of prove some of our first theorems in geometry, which is pretty exciting stuff. And that is that whole section. So my plan is to go back through this and kind of edit it, cut out some of the long pointlessness. Not that there was any of that. I mean, what am I going to do? Cut out being randomly blown up by a creeper? Of course not. Cut out almost dying to a witch? Of course not. That's not going to happen. No, but there will be some editing, and the places where I'm just talking about things, maybe add in some nice figures and things like that. And also add in some examples and maybe extra practice. That's the plan. But as far as the live streams go, I want it to be mainly playing Minecraft, showing examples where I can in Minecraft of visually what things would look like. And then, yeah, talking math, playing Minecraft. Those two things together. And dying as little as possible. I almost don't want to say this, but I have not yet died in this game, I don't think. Which is pretty exciting, not gonna lie. That's, I should plant flowers on my roof. I think that's a great idea. I think that's probably one of the best ideas I've ever heard. On the roof of my current house, or on the house I plan to build and have be spectacular. Which I feel like I could actually do both. I feel like this is a good way to kind of end things for today. Probably should bring my sword back to have handy. Oh no, it's night. That's okay. We'll get a new day. Then we'll plant. Thank you for that suggestion, Evie. And if I actually know you in real life, you're going to have to let me know. Because I'm suspicious that I might know who that is, but I could be totally wrong. That seems like a problem. There we go. At least it's flat now. Okay. So, I'm gonna put this purple flower in the middle. Red flower here. You can't put flowers on sandstone? Okay, that's fair. That makes sense. You right, Minecraft, you right. I'm gonna be really artistic about this. Wait. Yeah, okay. And symmetric. Because those are both beautiful things. Okay, I feel like I failed the symmetry here. I totally failed it. That's fine. It's no big deal. Okay, let's take a look at this from afar and see how it looks. I like it. Oh, I almost just fell. I need to cover up that hole. I like it. I think it looks great. Let's check it out from the top of these stairs. Beautiful. I think that should be a part of every home, is a nice selection of flowers on top. Alright, this all needs to be less of a scary thing. Because I do not want to die by falling. Or any other reason. But especially falling, I feel like would be kind of a low blow at this point. After all the other things I've survived. I've gotten blown up by so many stealth creepers, which is actually like a repetitive statement, because all creepers are stealthy. But I'm just saying. I don't actually remember how much of this mine I explored. I guess I was mainly using it to get the rocks that I needed for the coordinate plane. Okay. So, what I need from you if you're watching later or if you're watching now and you're able to, I need to know what should I build my house out of, or other suggestions about what the house should look like, because I'm going to build a really epic house next to the coordinate plane, because why isn't that a thing? Like, don't you have to build epic houses in Minecraft? Does anybody not do that? I don't actually know what people do in Minecraft. If it's not look for obsidian to make a purple house. That's my best guess. I feel like I may be making it impossible for, you know, I can get down from here from my house if I do completely cover this hole. And that way I won't fall down. And look, I can plant some more flowers. Ore? I should make it out of ore. What kind of ore? And hello. Oh, you know what would be a terrible idea? To make a house out of, like, gold. Like, what does that even look like? Can you set down, like, bars and it be a thing? Or do you have to, can you make blocks? Oh no, I stuck something on top, so now I can't open that. That was a bad plan on my part. And also, I didn't need to put it on top anyway. Wait. There we go. Let's see if that works again. Yay! Although that's not where my gold ore was. I mean, bars. Like, nope. Okay, can't place gold ingot. Can I, and I can't make a gold block. But, what was that? A gold pressure plate? Gold. Light-weighted pressure plate. Interesting. Well, I'll have to think more about that. I don't want to make a house out of gold, of course. Because that would be silly. Oh wait, well, I'm going to call it quits here for this stream. Thanks so much for watching, and I will see you guys tomorrow night, I believe, hopefully.